You think you know what speed means. You've felt it in cars, on bikes, running down a hill. Speed feels like the simplest thing in the world. Then I ran into an idea that changed what I thought motion even was. It's the kind of thing that keeps you awake, because once you notice it, you can't stop turning it over. Picture this. You're on a train and you throw a ball straight up. From your seat, it rises and falls in a neat straight line. But someone watching from the platform sees something else. The train is moving forward, so the ball moves forward too while it goes up and down. From outside, the ball traces an arc through the air. You're both right. The path you measure depends on how you're moving when you measure it. Now, here's what broke my picture of the universe. Light doesn't work that way. Not at all. In 1887, two American scientists, Michelson and Morley, ran a seemingly simple experiment. They split a beam of light and sent it in different directions, expecting to measure tiny differences in its speed as Earth moved through space. They found nothing. No matter how Earth moved, light speed stayed exactly the same, 299,792,458 meters per second. That makes no sense if you're thinking in the old. It's like the ball on the train, except now everyone, the person on the train and the person on the platform, sees it moving at exactly the same speed. Impossible, right? I thought so too. But that one stubborn result unravels everything we thought we knew about space and time. Picture yourself chasing a beam of light. You go faster, then faster still, with normal things you'd expect to gain on it. From your point of view, the light should seem to slow down. The way the ball's motion looks different, depending on who's watching. But it doesn't, ever. No matter how fast you go, light keeps the same speed. It's as if the universe has a speed limit posted everywhere, written into the fabric of reality itself. So why? I spent years wrestling with that. And the answer forces a hard conclusion. The only way this can work is if space and time themselves change, just to keep light's speed constant. Think about the ball on the train again. We add speeds, train plus throw, because we're assuming space and time stay fixed in the background. With light, something has to give. And what gives is stranger than anyone expected. When you move very fast, time itself slows down. Space contracts. Mass increases, not as an illusion, but as a physical reality. The faster you go, the more these effects intensify. As you approach the speed of light, time would nearly stop. Your mass would approach infinity, and your length would shrink to almost nothing. That's why nothing can reach light speed. The energy required would be infinite. The universe pushes back, warping space and time to enforce its speed limit. But why? What makes light so special that the structure of reality bends to keep its speed constant? Go back to the light beam for a moment. Imagine two observers watching the same flash. One is standing still. The other is racing past in a spacecraft. Both measure the light speed with perfect instruments. Both get exactly the same number. 299,792,458 meters per second. Hold on. If they're moving relative to each other, how can they both measure the same speed? It's like two runners on different tracks somehow taking the same time to reach the finish line, even though one track is clearly longer. That paradox forces a radical possibility. Maybe the disagreement isn't about the light's speed. Maybe it's about distance and time. Now picture two identical clocks. Put one on Earth. Send the other racing through space at nearly light speed. When the traveling clock returns, it shows less time has passed. Not because it's broken, but because time itself flowed differently for the moving clock. This isn't speculation. We've done this with precise atomic clocks. The moving clock always runs slower. Always. And here's where it gets truly strange. From the perspective of the person with the moving clock, it's the Earth clock that runs slower. Both observers see the other's clock running slow. How can both be right? Because the old idea of time is wrong. There is no single, universal now. What one observer calls simultaneous Another observer, moving relative to the first, will see as happening at different times. The flow of time itself depends on how you're moving. Remember Michelson and Morley? They were looking for tiny changes in light speed as Earth moved through space. They found none because they were asking the wrong question. They assumed there was an absolute reference frame, the cosmic, at rest, against which all motion could be measured. But there isn't. Motion is always relative. When you say something is moving at a certain speed, you have to ask, relative to what? The Earth? The Sun? The center of our galaxy? Each reference frame is equally valid, and in each one, light maintains its speed. That leads to a deeper truth. Space and time are not separate things. They're aspects of a single entity, space-time, and space-time can stretch and bend. Think of a stretched rubber sheet. Put a heavy ball in the center, and the sheet curves around it. In a similar way, massive objects curve space-time itself. Light follows that curvature, which is why gravity can bend light beams. But before we get to how space-time curves, there's an even more radical implication of light's constant speed, one that challenges our basic notion of cause and effect. Is the part nobody tells you when they say, casually time slows down. If you take it seriously, you run straight into a fear. You might be able to change the order of events. You might be able to make an effect happen before its cause. And if that were true, physics would collapse into nonsense. So let's test it with something you can actually picture. Imagine you and I standing on a long train platform at night. Far down the track, there are two lamps on posts, one to your left and one to your right. You're standing exactly halfway between them. I asked the two lamps to flash at the same time, so the light from each has the same distance to travel to reach your eyes. You see the flashes together. In your mind, you can almost hear the little click of the switches, perfectly synchronized. You say, simultaneous. Now watch what happens when you're moving. I put you on a fast train that passes through that midpoint. At the instant you pass the middle, the two lamps flash. You're moving toward one flash and away from the other, since light speed will not adjust to your motion. The light coming toward you reaches you sooner, and the light you're moving away from reaches you later. You don't see them together, so you say. They did not happen at the same time. No, not quite. You might try to rescue the old idea by saying, it only looks that way because I was moving. But in physics, looks isn't an insult. What you can measure is what you can measure. Remember Michelson and Morley tried to catch Earth moving through space by measuring changes in light speed. They failed because nature refused to give them a preferred state of rest. Light did not care how Earth moved. So who gets to claim the true simultaneity? The one on the platform or the one on the train? Neither gets special authority. That's the point. If light speed is the same for all observers, then your verdict about same time cannot be universal. Simultaneity is not a fact written into the world independent of you. It depends on your motion. This is the first twist you can't afford to forget because it answers the loop we opened earlier. How can two people both be right when each says the other's clock runs slow? They disagree about which moments line up across distance. They disagree about what at the same time means. Once you allow that, the apparent contradiction dissolves like mist. But I promised you a deeper worry. Cause and effect. Imagine a very distant star sends a burst of light toward Earth. You and I are moving relative to each other. Could you ever see the burst arrive before the star sends it? Could motion reshuffle time so badly that before and after swap places? If signals could travel faster than light, then yes, you could get into this trouble. You could find a frame of motion in which the reception comes before the emission. It's not magic. It's the geometry of time. Once simultaneity is not universal. Faster than light communication would let you build a kind of cosmic reply before the question is asked machine. You might laugh, But this is exactly why the light speed limit isn't a random speed limit, like a sign on the road. It's a protection built into the structure of cause and effect. Here's the clean version. As long as nothing carries information faster than light, all observers agree on what can cause what. They may disagree on the time gaps, but they cannot disagree on the basic order for cause-connected events. So the limit is not only about energy, it's about keeping the universe logically consistent. Now let's go back to Michelson and Morley, because their experiment is still speaking. They built an instrument, an interferometer, meaning a device that compares light paths by making patterns. They sent one beam of light down one arm and another beam down a perpendicular arm, then recombined them to see whether one beam was delayed. If Earth moved through a medium for light, like a wind through an invisible ocean, then one beam should take slightly longer, depending on direction. The recombined light would shift its pattern like ripples slipping out of step. The pattern refused to shift. People tried to save the old world with patches. Perhaps, they said, the apparatus shrinks in the direction of motion through this invisible medium. That way, the travel times would match by coincidence. That idea was close to the truth, but it was treated like a trick. A mechanical squeeze applied to matter moving through the ether, meaning an imagined invisible substance that carries light. But why would every material shrink by exactly the right amount? Always, without anyone ever seeing the ether itself. It was an ugly story. I took a different route. I said, remove the ether entirely. Keep only what experiments actually demand. And experiments demand two things. First, the laws of physics look the same in any steady motion. Second, light in empty space has the same speed for all observers. Once you accept both, the shrinking isn't a special punishment for moving through an ether. It's simply what space and time must do so that everyone, moving or not, measures the same light speed. Length contraction, meaning moving objects measure shorter along motion, becomes a consequence, not a conspiracy. Time dilation, meaning moving clocks tick slower compared to you, becomes a consequence, not a malfunction. And now you can answer another loop we opened. Why can't you catch up to a beam of light? Because as you push your speed higher, you don't simply add more speed the old way. Instead, the universe pays by changing how much time passes for you and how distance is measured in your direction of motion. It's like trying to run up a moving walkway. It speeds up precisely to keep the finish line at the same light-like pace away from you. The harder you run, the more the floor itself changes the meaning of your effort. A refrain helps here. Light is not adjusting to you. You are adjusting to light. And don't make the mistake of thinking this is only about light bulbs and mirrors. It reaches into matter itself, because if space and time mix, then energy and mass, meaning the stuff of motion and the stuff of matter, are linked in a way that shocked even me. If you trap enough energy in a box, the box becomes heavier. If something loses energy, it loses a tiny bit of mass. This wasn't a philosophical flourish. It was a physical statement about the bookkeeping of the universe. And now, a new question, sharper than before. If light sets the limit and forces space and time to bend their meanings, what happens when gravity enters? Does gravity also have to respect this limit? And if so, what is gravity really, if not a force pulling through space, but something shaping space and time themselves? Hold that question. In a few minutes, I'll show you why the speed of light is not only a limit for rockets, but a limit for how fast reality can update itself, and how this leads, inevitably, to curved space-time and the strange practical miracle that your phone can tell you where you are. Let's take the next step carefully, because this is where people rush, then complain that relativity is mystical. It is not mystical, it is strict, it is almost annoyingly strict. You already know this. Michelson and Morley found that light speed does not change with Earth's motion. We return to it twice for a reason. Once you accept that result, you're forced to accept that different observers will not agree on what at the same time means. And once you accept that, you're forced to accept that there must be a universal speed limit for cause and effect. Not a limit of engines, but a limit of logic. Now we add gravity. If gravity were an ordinary force that acted instantly across space, then it would break this limit. The sun could tell Earth to move in a new way instantly, but light refuses to carry information instantly. So gravity must also obey the same rule. Changes in gravity must travel at most the speed of light. That single requirement already puts pressure on the old picture of gravity as a simple pull through empty space. It becomes more natural to think of gravity as part of the stage itself. Let me give you a picture you can feel. If space-time, meaning the combined fabric of space and time, were like a stretched sheet, then matter is like a heavy object pressing down, making a dip. This is a metaphor, and roughly it helps, but you have to remember it is not a real sheet in a real room. The important part is the idea of shape. Objects do not feel a mysterious tug from far away. They follow the straightest paths available in a curved geometry. Like a marble rolling on a warped surface, they curve not because someone pulls them sideways, but because straight has been redefined by the shape beneath them. This is why light can bend near the sun. Light has no mass in the ordinary sense, but it still follows the geometry of space-time. If space-time is curved, straight light looks curved to you. Nature is not pushing the light like a hand on a string. The path itself is bent. And now we can close a loop you may have been holding since the beginning. Why does the universe push back harder and harder as you try to approach light speed? The pushback is not a wall sitting at the speed of light. It is the structure of space-time refusing to let cause and effect become inconsistent. As you pour in energy to go faster, you do not get simple added speed the way you do with a thrown ball. Instead, you get more distortion between your time and someone else's time, between your measured length and someone else's length. The more you demand, the more space-time takes the payment in a different currency. Let me return one last time to Michelson and Morley, because it deserves a kind of respect. They did not find an effect, but that nothing was the loudest answer nature could give. It was the universe saying quietly, stop asking for the ether, stop asking for absolute rest. Ask instead what measurements mean. When I accepted that, the world became simpler, not more complicated, not easier, but cleaner. The rules did not multiply. We removed an invisible medium and kept only what could be tested. Now you may still ask, if time can run differently, if now depends on motion, is this only philosophy? Is it only an argument about how you label events? No, it is engineering. Near the end of our story, I want you to think of a clock in the sky. A GPS satellite carries clocks, atomic clocks, meaning clocks that tick using atoms' steady rhythm. Those satellites move fast, and they also sit higher in Earth's gravity, where gravity is a little weaker. Both motion and gravity change how time flows. The satellite clocks would drift compared to clocks on the ground. If engineers ignored this, your phone's position would wander by kilometers in a single day. The system works because we correct the clocks using relativity, not as poetry, as maintenance. So the limit is real. The bending of time is real. The bending of space is real. Your ordinary life is soaked in it, even if you never notice. Now I want to bring you back to the opening scene. Remember the train and the ball, the simple comfort that we can add speeds. Remember how harmless that felt? Here is what it was really showing you. The ball could behave that way only because time was assumed to be the same for everyone and everywhere. The old world hid that assumption so well you did not notice it. When you threw the ball, you were also throwing your unspoken belief that the universe carries a single, shared clock. Light exposed the hidden assumption. Light behaved like a stern teacher. You expected it to act like the ball. It refused, and in that refusal, it revealed that time is not a universal river flowing the same for all. It is more like a landscape that can tilt and warp, and your motion decides which way you are walking across it. So what is the speed of light, really? It is not only the speed of a thing, it is the conversion rate between space and time. It is the pace at which cause can reach effect. It is the rule that keeps the universe from contradicting itself. If you want a worldview reframe you can carry with you, take these lines and keep them simple. Space is not a container. Time is not a master clock. Reality is a single woven fabric, and motion tugs on the weave. And I have to say one honest sentence, because honesty is part of science. We can predict it, but we don't fully know why. We can write down the rules that match every test. We can build machines that depend on them. We can watch light bend and clocks drift and particles live longer when they race. But why the universe is built with this particular limit, with this particular structure, is still a deeper question than my theories answer. Still, when you feel the temptation to think of light speed as merely fast, remember Michelson and Morley staring at their stubborn, unmoving pattern. Remember the train where same time split into two honest answers. Remember that the universe did not change light to fit your common sense. It changed your common sense to fit the universe. And here is the final sentence I want to leave you with. The one you should not be able to unhear. The speed of light is not the fastest thing in the universe. It is the speed at which the universe is allowed to make sense.